Okay, so let's go over this entry task. So you'll notice here that this is a very stereotypical problem that could show up on your guys' test. This is an absolute value equation, and it's your job to find the values that make this equation true. So one thing that I definitely want to emphasize here is to make sure you understand that before you start making your two equations, you have to isolate your absolute value. So you'll notice that if I look on the left side of this equation, I have to get rid of this 7. I have to get rid of this negative 5x. Now, both of those terms are getting added or subtracted, so it doesn't really matter which one you get rid of first, as long as you make sure to get rid of them. So I'm going to start with the 7 and minus 7 on both sides. Now, notice I put this right under the 12 because those are like terms. Those are the ones I can combine. Now, just to save a little time, I might as well add 5x to both sides to get everything on one side, or get the absolute value isolated, really. So notice that these are going to subtract and add out. I'm going to be left with the absolute value of 4x plus 1. Looking on the right side, I'm going to combine like terms. So negative 3x plus 5x is a positive 2x, and 12 minus 7 is a positive 5. So double checking my work, make sure I got my negatives and positives. It looks like I believe I got it right. So I'm going to go ahead and make my two equations now. And remember, the reason why I can make my two equations now is because my absolute value is isolated. And I'm going to go ahead and do that over here just because there's a little more space. So I'm going to go ahead and set the inside, 4x plus 1, equal to a positive solution, 2x plus 5. And then I'm going to go ahead and set the inside. Now I'm going to do it over here to this side, equal to a negative. Now keep in mind that your whole right side is negative. So what I'm going to do, just to ensure that I don't make mistakes, is I'm going to put this in parentheses, so that way I know that I'm making everything on the right side negative. And when I saw this equation, you'll notice that there's a step that a lot of students make, and I'll highlight that in a second. So let's go ahead and solve this one. Sorry for jumping around, but I want to make sure to have enough space here. I see I have variables on both sides, so I'm going to move all my variables to 1. I'm minusing that 2x minus 2x is a positive 2x, plus 1 is equal to a positive 5. Now, isolating that x, I'm going to minus 1 on both sides. You end up with 2x is equal to a positive 4. Finally, dividing by 2, x is equal to a positive 2. So that's my solution. If I were to plug this in, that'd be good. Let's go ahead and solve the other one. Let's start by distributing this negative. We'll end up with 4x plus 1 is equal to a negative 2x and minus 5. Now, make sure that you completely distribute this negative. Make sure you have a negative 5. That is where 99% of the mistakes happen if there's a mistake in these problems. Now let's go ahead and solve this. I'm going to move my x over by adding 2x. To both sides, these are subtract out. You end up with 6x plus 1 is equal to a negative 5. Minusing 1 on both sides. 6x is equal to a negative 6. And then finally dividing by 6 on both sides, you end up with x is equal to a negative 1. So remember that, yes, I found two solutions, but keep in mind when you have variables on both sides when solving absolute values, you always have to check them. Now you can check these in different situations. What I mean by that is when you can either plug it into this equation or plug it into this equation, but always make it easier yourself. Look for where your absolute value is isolated and see if it's going to be equal to a negative if you plug in the values that you found. Because remember, an absolute value cannot be equal to a negative. Let's plug in this 2. 2 times 2, if I were to plug this in, 2 times 2 is 4, plus 5 is a positive 9. That's okay. Let's plug in a negative 1. 2 times negative 1 is a negative 2, plus 5 is a positive 3. So it means that both of these could be solutions. You're good to go. Make sure you include them both in your answer key. If one of these did not work out, or if it gave you a negative, you would have to tell me that one way or the other on your answer key. So make sure that you're doing that. So again, this is a very stereotypical problem that you might be able to get on your guys' test on Monday. Make sure you let me know if you have any questions, so that way we can go over these. Now today we're going to start solving what are called compound inequalities. So before we even start talking about compound inequalities, let's talk about inequalities. Now, can anyone here help me out? Does anybody remember what are inequalities? What do you think, Mr. Juan? Do you have some experience with inequalities?
I do, but honestly, I don't remember what they are.
No worries, because once you start seeing these examples, I'm sure it'll come back in. And this is why I always like to start with the basics, man. I never like to assume that you know these, because I know you probably went over these 3 times, but you've done it in the last 5 years, so it's sometimes hard to remember. So let's start talking about what are inequalities. Inequalities are literally just mathematical statements that compare the sizes of 2 expressions. Now that is just a definition. What they look like mathematically are these little fancy symbols here. Now, I'm assuming you guys have probably worked at these like in the 3rd grade level, 4th grade, where the alligator always eats the bigger side. And that's just like a little memory thing to help you remember exactly what these symbols are doing. And what they're doing again is comparing sizes. They're saying that one side of the inequality is bigger or equal to the other side. Now, how in the world do we know which one's bigger? Well, if you look at the inequality symbol, it looks like a little alligator. And I'm sure you guys will probably remember this from 3rd grade. That symbol is always going to be open up. It's always going to eat the bigger side. So if I look at this specific inequality here, I know that the right side here is greater than the left side. So if the right side is greater than, that means that this side is less than. And that is literally all an inequality is. It's comparing one side to the other in terms of size. The greater side is always going to be bigger in the side that is opened up or whatever. So if I look at this bottom one here, notice that it's opening up to the left. That means that the left side is going to be greater, or the left expression is going to be greater than the right side. But the right side, if the left side is greater, that means that the right side is less than. Hopefully I said that right. I think confuse it with lefts and rights, but there we go. Now that is the very, very basics of what inequalities are and what they are used for. Now keep in mind that they also can have this little line underneath inequality. Now that does not change which side is greater. If I'm looking at this one, I can see my inequality is opening up to the right, so I know the right is greater than. And my left side is less than. Now, keep in mind that whenever you have this line, it's also an option that could also be equal to. So this symbol, it depends on which way you're reading, left to right or right to left. If we're going from left to right, this would be less than or equal to the right side, or working backwards. So that means that this symbol says that not only could one side be greater than or less than, but it also might be equal to. And the same thing goes for this one. Notice it opens up to the left, so that means the left is greater than. That says greater than, by the way, or equal to the right. Or if you're working backwards and reading it, it's less than or equal to the right. Depending again on which way you see it, because obviously if one side is greater, then that means the other side is less than. But again, when you throw that little line in there, they could also be equal. All right, so hopefully that was a good basis. Let's start doing some kind of basic problems to see if we got this down and we understand what these mathematical symbols are telling us. So looking at number 1 and 2, I want you to let me know if the following inequality expressions are true or false. So notice here in number 1, I have a left side, I have a right side. According to this symbol, the left side is greater than or equal to the right side, and it's your job to make sure if this statement is true or false. Now, how in the world do we do that? Well, I know I have a left side. Let's go ahead and figure out what the left side is telling me. I notice I have the absolute value of negative 10 plus 5. Remember, we worked on simplifying these expressions in our last class. Let's start with simplifying everything underneath the absolute value. Negative 10 plus 5 is a negative 5. Don't forget, you're still taking the absolute value of it, divided by 5. Now, taking the absolute value of negative 5, it's a positive 5. Don't forget to divide it by 5. And we'll see that 5 divided by 5 equals a positive 1. Now, ignore this little guy kind of writing below it. So notice what I did there is I simplified the left side as much as possible. And the reason why I did that is because I need to compare it to the right side. Now, luckily for me, the right side is just a 1. So let me just go ahead and fill out my mathematical statements. Now, looking at this statement, is this a true inequality statement? Is my left side less than or equal to 1? And I believe the answer would be yes, right? Because 1 is equal to 1. So that means that this is a true statement. That means this inequality holds true. So go ahead, try number 2. If you're feeling confident, go ahead and try the bottom ones and we'll go from there. All right, guys, so we had just completed number one. Let's go ahead and see if my second inequality is true. So looking at number two, I can see that there is a left side that this inequality states is less than the right side. So it's my job to figure out if this is actually true. Now keep in mind that my right side is a 1. It's pretty easy to compare 1 to anything because I know my numbers. Now, I need to figure out what -2 times 5 plus 8 is. So let's go ahead and figure this out. 5 plus 8, again, I'm starting with my work inside the parentheses because of PEMDAS. 5 plus 8 is a positive 13. I'm not going to forget to multiply it by my -2. -2 times 13 is a -26. Now, I actually wrote my wrong inequality. It's less than 1, less than 1. I wrote that down to pretty much compare my last statement and think about to see if this is true. Now, is -26 less than 1? I would say that that is an absolute true statement. -26 is less than 1, so this is a true inequality. Of course, these could be true, they could be false. It's your job to figure it out. All right, so looking at the bottom one, notice that I have an inequality with a variable. So if I read this inequality here, I can see that x plus 12 is greater than 7. Now, is this a true inequality? Well, that depends on what the value of my x is. Now, sometimes I'm going to tell you to test the value. Sometimes I'm going to tell you to find the value. Right now, what I'm doing in these specific 3 problems is asking you to check if -5 is a solution. So I want you to plug a -5 specifically into this inequality and see if it is a solution. So let's go ahead and do that. Now notice I have x plus 12. I know my x equals a -5. So -5 plus 12 is greater than 7 according to this inequality. Now, whether it is or not, it's my job to find out. So let's go ahead and do that. Looking at the left side, I have -5 plus 12, which is just a positive 7, greater than 7. Now, is this a true statement? Is 7 greater than 7? And I would say that that is absolutely false. 7 is not greater than 7. It's equal to 7. So is this a solution to this specific inequality? No. Now, the next thing I want you to go do is try to see if you can do number 2. Just for time's sake, I'm not going to worry about number 3. But try number 2. We'll start talking about interval notation, and we'll graph these a little bit, and we'll start doing the equations, especially compound equations. So go ahead, try number 2. I'll give you guys about 20 seconds. All right, so looking at number 2, we're going to go ahead and check to see if -5 is a solution to this inequality. Now, according to this inequality, 1 minus 2 times a variable p is less than or equal to a -9. Now, we're going to go ahead and test to see if this inequality holds true for that specific value. So I'll notice here that I have 1 minus 2 times whatever my p is. Now, my p in this situation is going to be a -5. Should be less than or equal to -9. Or I guess we're going to test to see if it is. Now, looking at my left side, there's no work to be done inside of these parentheses, but there is, there's no exponents, but there is multiplication here. So notice that this is a -2 times a -5, which equals a positive 10. And that is less than or equal to a -9. 1 plus 10 is a positive 11, which is less than or equal to a -9. Now, is this a true statement? And the answer would be no. So that means that this is a false statement. That means -5 is not a solution, because 11 is not less than or equal to a -9. Again, make sure that you're taking your time to read those inequalities to see if it is true. Now, you'll notice here in the very first ones, what I did is double check to make sure you know the basics of inequalities, whether a inequality is a true statement or a false statement. And then I had you choose a specific, or I didn't have you choose, I gave you a specific value to choose to see if it works for a specific inequality statement with variables. Now, you can see here that sometimes I might want to know solution to many of them or all of them. And that's what we're going to start getting into. And the best way to do that is just to visually graph these inequalities. So let's go ahead and do a couple of these examples. Let's say I want you to graph the following inequality and write them in interval notation. I'll go over what interval notation is in a second. I want you, the first thing to do in this problem is to graph all the numbers that are greater than -1. That's the first thing I want you to do. So looking at this number line, I see that my -1 starts here. Now, I want all the numbers that are greater than. So If I'm looking at number one, where are my values greater? To the positive side of my number line or the negative side of my number line? And I would say that it is in the positive side, right? Because the numbers get greater when you go to the positive direction. So that means I'm not only going to show a little open dot to say, hey, start at -1. I'm going to point an arrow going to the positive direction to tell my reader, hey, man, my solutions, all the numbers that you are looking for are the numbers that are going to the right. And you can see that all these values over here would be a solution to what we're looking for, which are all the numbers that are greater than -1. Now, notice that number 2 is pretty much the same thing, except it's changing a little bit. They're asking us to find all the numbers that are less than or equal to 5. Now, if I were to locate 5 on this number line, I would have it right over here. Now, they're asking for all the numbers that are less than. So if I'm looking at this number line, where do the values get less than? To the left of my number line or to the right? You'll notice that they get less than when you move to the left, to the negative direction, because those numbers are less than. So I'm going to make a very obvious line to show that, hey, these are my solutions. These are the numbers that you are looking for to the reader. Now, keep in mind that there is a huge difference between these two problems. One of the problems is asking all the numbers that are greater than -1. So it's not including that value of -1. I want the numbers that are bigger. This one wants it less than or equal to. So you need a way to tell the reader, hey, 5 also works. And the way we do that is by not only just putting a little open dot, but we actually fill it in to tell the reader, hey, man, the solutions are also including 5. So make sure that if it is just greater than or less than, open circle, close circle, if it is also equal to. Now, again, this is how we graph inequalities, or at least the start of how to, but I also want you guys to be able to put it in interval notation. Excuse me. Now, interval notation is just a really quick hand way of writing down the least and greater values that you're looking for. So if I look at number 1 here, let me change colors so that way you can see what I'm emphasizing. I can see here that my values start at -1 and they go all the way to 10, 11, 12. They go all the way to positive infinity. So you need to have a way to write it. So the way we do it is we write a little comma. To the left of the comma, we write where our values start. You can see our values start, our lowest value would be a -1. And then they go all the way to positive infinity. So the way I'm going to show that mathematically is just by writing a little infinity sign like that. Keep in mind here that we're not including that -1. So in order to show that we're not including them in this shorthand, I'll put a little parenthesis there to tell the reader, hey, I'm not including the -1. Technically, mathematically, you cannot include infinity. So you have to have parentheses around infinity as well. I know this looks like an ordered pair, but interval notation, again, is just somehow, but not somehow, it is a way that math people use to pretty much give the same information that you see above, but in a shorthand mathematical way. Now, let me show you another example here. I can see here that my values end at -5 and they go all the way to -infinity. So what is the least value that works for this statement? Well, it's going to go forever and ever to the left. So that means it's going to go all the way to -infinity. And notice that my biggest value that I could get that works would be a +5. Now it is including that 5, so I'm going to put a little bracket to tell the reader, hey, include number 5. Again, it's a mathematical thing that you cannot include a specific value in infinity, so I'm always going to have those parentheses around. So yeah, this is kind of the basics of interval notation. I know some schools use it, some don't, some algebra 2s cover it before, but again, it's just a little bit of practice and shorthand. So let's make sure that we got it, okay? All right, guys, so another thing I'm asking you guys to graph all the numbers that are less than 10. Now, I completely understand that more than likely you guys are not going to have these number lines with you. So let's say, for instance, that I'm asking you to do this on your homework on a test or something like that. The first thing I want you to do when graphing the solution is to draw a number line or write a number line. Always include your 0 right in the middle, and then tell me what value you're starting at, whether it's -10 or +10. I can see here that I'm to show you visually or graph all the numbers that are less than 10. So I know that 10 is somewhere to my right because it's a positive 10. Now, again, I don't care if you count all the tick marks or the scales. All I want to know is that that 10 is somewhere in that direction. And then I just want you to graph it like normal. So we're graphing all the numbers that are less than 10. I know that 10 exists right here, so I'm going to leave an open dot. Now keep in mind I'm leaving it open. I'm not filling it in because it's all the numbers that are less than 10, not equal to 10, that are less than 10. Now looking at the number line, I know that my negative values are to the left. That's where my less values are. So I'm going to draw a big arrow to tell my reader, hey, this is where all your solutions are at. Those are the answers to what you are looking for. Now looking at this in interval notation, again, I always want to start with my least value to the left. Now I notice that my least value technically is infinity because it's going to keep going negative and negative and negative. So I know it's going to go all the way to negative infinity. Now remember, to the right is always going to be the greatest value, which in this situation is a positive 10. Now we're not including it, so it's going to be an open it's going to be a parenthesis. And infinities always have parentheses because again, it's not a very specific value. It keeps going and going and going. All right, so just so that way it seems a little bit more like what you guys are doing, I'm gonna go ahead and write my number line. I'm gonna start with 0 in the middle. I can see that the value of 3 is somewhere to the right because it's positive. I'm looking for all the numbers that are greater than or equal to. So here is where 3 is at. It's including 3, so I'm gonna leave an open dot. Now, where are my values greater than? Those are the ones that I'm looking for. Well, they're going to be greater in the positive direction. So I'm going to draw an arrow or write an arrow pointing to the positive to tell my reader, hey, all your solutions are to the right, where all your positives are, where they get bigger. Now, let's go ahead and do some interval notation. I can see the first value, my least value that shows up, the ones I'm looking for specifically, is a 3. My biggest value is always going to be, it's going to be positive infinity, which is to the right. Now, do not forget that you need to make a clear bracket at 3 because we're including the value. Infinities never have brackets because technically it's not a specific value. It's going to keep going and going and going and going and going. All right, so inequalities have so much information. You guys spend about 2 weeks, almost I believe 3 weeks on inequalities because there's so much things. I know it feels like I'm kind of moving fast, but again, this is review. I'm hoping those wheels are turning and you're remembering exactly how to deal with them. So what I'm going to ask you guys to do here is to dig deep in your guys' memory bank and think about what is that thing you have to watch out for when dealing with inequalities and solving for inequalities and graphing them in terms of like problems like number 1 and 2. Does anybody remember? And I'll tell you, so whenever you're multiplying or dividing with inequalities, there's one property you have to look out for, and that is when you divide or multiply by negatives. Because whenever you divide or multiply by negative to an inequality, the values actually change, your inequality changes. Let me show you what this looks like with a very, very specific problem. And very simplified. Let's start with something that we know is true. Let's think about it. I know that 10 is less than 20. Now that is true just because I know 10 is less than 20. Now, if I were to multiply both sides of my inequalities by 2, I'd end up with 20 is less than 40. Now, is my inequality still true? And the answer is yes, or it remains the same. 20, the left side is still less than the right side. Now, let's see what happens if I multiply by negative, like a negative 2 on both sides of my inequality. I end up with a negative 40 is less than a negative 80. Now, is this a true statement? Is negative 40 actually less than negative 80? And the answer would be no, because negative 40, when you have a smaller negative, is technically greater than, because we're dealing with negatives. So this is what that property states, the thing you have to watch out for. Whenever you're doing something to one side of inequality and the other, if you ever multiply or divide by negative, you have to flip your inequality, because technically you're changing the values when dealing with negatives and positive number lines. I mean, this goes for division as well. Let's say we started with our original problem, 10 is less than 20. We were to divide by, I don't know, negative 5 on both sides. Negative 10 divided by 5 is a negative 2. 20 divided by negative 5 is a negative 4. Notice that negative 2 is greater than negative 4. So notice that my inequality flips. You have to make sure that you remember this property when solving equations. And let me show you what that means like in a second. I gave you two problems. I'm asking you to solve and graph the following inequalities, starting with this guy over here. Now notice that this is stating 3 times 2q minus 4 is greater than 6. Now, looking at this equation, solving for this equation, the first thing that I see here is 3 times 2q minus 4. I'm going to go ahead and distribute that. Notice I end up with 6q minus 12 is greater than 6. Now, solving for my q over here, what I'm going to do is add 12 to both sides. 6q is going to be greater than a positive 18. Finally, dividing by 6, q, right over here for space reasons, q is less than 3. Now, keep in mind that I multiply or divide by any negatives anywhere in this string of math work on both sides of my inequality. The answer is no. So luckily for us, we didn't have to change anything. But notice here that q is greater than 3. I have to graph it. So here's my 3, open circle. Notice that q is greater than. So remember, your variable is your answer. That's what you're looking for. So if my q is greater than 3, where are those values? Where they're to the right side, because those are where they get positive, where they get bigger and bigger. So go ahead and try number 2. I'll give you a couple seconds. We'll do conjunctions, disjunctions, and we'll call it a day after that. All right, so I'm gonna go ahead and erase all my work so that way I don't get things confused. So I notice here that I have a negative m is less than m plus 4 divided by 9. Now it is your job to solve its inequality. You need to find the m's that make this inequality true. And we're going to solve it just like an equation, but we're going to keep in mind that if we ever divide or multiply by negative on both sides, we're going to flip our inequality. Now, when I'm looking at this thing, this fraction gives me a little bit of anxiety, so I'm going to go ahead and get rid of that as my first step. Now, luckily for me, when you divide by 9, multiplying by 9 is how you undo a division, so it's pretty straightforward. Those are going to divide out. 9 times a negative m is a negative 9m, which is equal to, not equal to, but actually less than or equal to m plus 4. Now you can see that I have multiple things going on. The first thing I'm going to do is move my m over by minus m on both sides. These are going to subtract out. You left with a negative 10m is less than or equal to a positive 4. Now keep in mind what I did there is minus m on both sides. I still haven't multiplied or divided by a negative. But now I'm going to divide by a negative 10 on both sides. The negative 10s cancel out here. You're left with m is greater than or equal to. Keep in mind that you divided by a negative. When you divide by negative on both sides, you have to flip the inequality. Positive divided by negative is a negative. Notice that I have 2 over 10, so I'm going to divide by 2 on the bottom to reduce to 2 over 5. So notice that my solutions are m is greater than or equal to negative 2 over 5. Choose any of those values. The left side is going to be less than the right side, or equal to the right side. So keep in mind that when you're graphing these, let's say that I don't have this graph right over here. I don't want you to overcomplicate it. I just want to have a visual of the answers. Your 0 still has to go in the middle. Negative 2/5 is somewhere over here to the left, sorry. It's going to be a closed circle because it is greater than or equal to. Now remember, m is your solution. Your m is greater than. Where are your values greater than? In the positive direction. So you're going to have an arrow pointing to the right.